So this is the continuation of the previous part 1 where I explained what we are going to do, and now we will start the configuration. Let's assume we got two 5K. Let me redraw. We got two 5K, 5K1, Nexus 5K1, Nexus 5K2. This is going to be VPC peers, and below, as for now, I'll just keep a normal layer 2 switch which can support Ether channel or a server. Assume any one of this is here, and we have redundant connection, one on the Nexus 5K1, another on the Nexus 5K2, and we are going to use both the links active, no STP, because we are going to have VPC. So there are some special server operating systems, they do support. So we can have server operating system with some switching capability, basic switching capability. Right, now we have the server or the layer 2 switch which supports Ether channel, and but Ether channel we need to we always do between two different switches only. We do not have three devices participating in an Ether channel. Always we have two switches, not more than two. But in our scenario, for redundancy, we have two boxes, but when we have two boxes, we cannot do Ether channel. If you don't do Ether channel, then STP will come and block one of the port, and I cannot use this link, and then I cannot use this switch. So to avoid this, what we do is we go for an advanced concept called VPC. What it does is it makes this two box to be seen as one switch. Now you can do normal Ether channel. If you have only one switch, if this will be considered as one switch, then this can form Ether channel with the downstream switch. That's what VPC provides. Now how we can make 5000 to act like VPC, virtual port channel. Now this one we called as VPC member. Let us assume that the interface name is Ethernet 1/1. Ethernet 1/1. For having VPC, two main things are like peer links. We need a peer link between these two switches, plus we need a Keepalive link. So this Keepalive link, it is recommended to use a management interface which is there in both devices, or we can also use some logical interface like SVI, switch virtual interface, with an IP address. Now let's say I got IP address 10.0.0.1 here on this management interface, here 10.0.0.2. So this is going to be used as the Keepalive link. Management 0. And let's say this one is Ethernet 1/2, Ethernet 1/3, and these two are going to act as peer link. Now because I have two links, I can do a normal Ether channel here. So let me call this ether channel as 2, group 2, port channel 2, and here on VPC let me call it as port channel 1. So port channel 1 is for the ether channel between the VPC peers and the switch or the server below, and port channel 2 is for the peer group. This is our plan, and our configuration is going to use these numbers only. And one more thing we learned in the theory, that for VPC we need a domain number. It's just a numerical number which helps to put all this thing together and handle it. So let's have domain number. It can be anything. I'll keep domain number as 12. It can be any number, but it should be same on both the side. I'll call it as domain number 12, VPC domain 12. Now this is our plan. Let's see how to do this. Now in Nexus, if you see, we will have a lot of VRF, default VRF, management VRF, same like MPLS. We'll have multiple VRF, virtual route forwarding. So for management interface, there is a special VRF called management. So this IP address that you assign to management interface will be part of VRF management. So when I try pinging from Nexus 5K1 to Nexus 5K2, I must source it from the VRF management. Say for example, if I am in Nexus 5K1, I want to first of all test whether I'm able to ping Nexus 5K2. I want to test whether I'm able to ping Nexus 5K2. So I want to ping from here. When I ping from here, if I say ping 10.0.0.2, I'll not be able to ping, even if there is proper physical wire connected between these two boxes. I'll not be able to ping. A dedicated wire is there, but still I'm not able to ping. The reason is management interface is not a part of any global routing table. In Nexus, everything is VRF. It belongs to VRF management. So we need to say ping 10.0.0.2 using VRF management. When we say this, we should be getting replies from 10.0.0.2. If it is true, if you get reply, then you are ready to go with Keepalive link configuration. So that's our first job. After we enable the feature, first of all we need to enable the feature called VPC, and then we need to enable another feature called LACP. Why? We are doing port channel. So LACP is the protocol that negotiates port channel. We need to enable the port channel. After that, what we do is we define a domain and we configure Keepalive, and then only we'll go and configure peer link. So that's the order that we are going to follow. First enable features, and then create a domain. Inside the domain, enable Keepalive. Then create this port channel, or if it is already created, use this port channel and say this port channel 2 is a peer link. Define it. You have a normal port channel here. Now you need to define that as what? Peer link. And afterwards we can go to this interface and say you belong to VPC. That brings to the end of our configuration. So let's do one by one, step by step. So we try pinging, the pinging is happening successful. Next is I go to 5K N5, next is 5K1, and I say in the global configuration mode, I say feature VPC, and then I say feature LACP. So it's the same command on Nexus 5K2. A replica. Not here. Not needed. Right now, it's a similar command. We do it on the other box. So I'll just put it as same command on the both side. So next thing is Nexus 5K1. I need to create domain name as we already discussed. If the license is already there, so that's the answer actually. You're asking, do I need to install? Yes, we need the license already. If license is already there installed, then you will have this. But you need to every time enable feature VPC, even the license is there, we need to enable this command. Alright, so that install is related to the license. Assuming that it is already there, we start the VPC here. Now, I need to create a domain. We discussed that we will use domain number 12. I'll say VPC domain 12. I'll be inside the domain now. So here, what is next? After creating the domain, we need to define this Keepalive. So how to do that? It's very, very simple. We need to use the command Keepalive. Peer Keepalive. Peer Keepalive. I am on first, means left hand side device. So what I'll do is I'll say destination, to whom I need to send the ping messages, to whom I need to with whom I need to check the connectivity, with the destination 10.0.0.2, which is the right hand side device. So you know now what to do on the right hand side device. On the right hand side device, same domain we will create, and here it's the same thing we will type, but the destination address will be 10.0.0.1. Is this clear, this part? Okay, so we just change the destination address. We go to the left hand side device and we give the IP address of the management interface IP address of right hand side device. On the right hand side device we give the management interface IP address of right hand side device. The next thing what we need to do is,
can we run two domains on this? Like we create VPC domain 12, right? Can we also create another domain like 14 or 13? That is not required.
yes, that's what I was about to ask. Why? Not necessary. Right. Now,
Assign these same devices to different domain as well. That is possible, right?
no, we can have multiple VPCs. Then why you want to have multiple domain? Same domain I can have multiple VPCs with a different port channel number. But for the downstream switch, it will see as only two devices. See, it is like this. For this switch, this is one VPC. I can have another layer 2 switch. I can have another VPC. Same domain. I can have another switch. I can have another one. No problem. Now these two are going to be seen as one logical switch for this guy separately. This guy separately. Why? Their port channel numbers are different. Need not to have multiple devices. So it was a good question. You yourself answered why we need it. No need. So this is again, Keepalive configuration, that is over. Next is we are going to jump into another important configuration portion section called peer group configuration. So peer link configuration. Peer link, we have two interface, Ethernet 1/2 and 1/3. So first of all, we need to go under the interface Ethernet 1/2, and we need to say what? We need to say switchboard, and then we need to say channel group. So what is the group number we were discussing? Group number 2. Channel group number 2. So even if you can say this Ethernet 1/2 and 1/3. Done. And then very important thing is we need to go to that interface. We need to go to the channel group, interface port channel, interface PO2, and we define it as peer link. This is the command VPC peer link. Right, this is inside the interface, and this is global. When you say channel group 2, port channel 2 will be created. So we go inside that created port channel, and we say whoever is member of this port channel, they are VPC peer links. So these two become peer link now. It's the same command, no difference. I do it on the other switch, so I put do. Done. So two main important thing is done. Now one final thing, last thing. This is the final thing. Now when I say peer link, what will happen is the moment we say VPC peer link, these two interface, the peer link interface, will automatically go into spanning tree mode network. Now when we say peer link, automatically it goes to network mode. Now what is the special of this mode? This mode, when it goes to network mode, whatever we learned day before yesterday, the bridge assurance, which is a loop prevention mechanism, bridge assurance, that bridge assurance will be enabled. Gets enabled automatically. So you will get a log message saying network mode changed to, spanning tree mode changed to network, and bridge assurance got enabled. So something like this, similar meaning, similar words will come, more or less same words you will see. You will get a log message. So this interface will not, even if STP fails, you will not have loop because of bridge assurance, which is cross-checking with layer 1 and layer 2, and it ensures that it makes sure that there is no loop. What it will do in case if it finds STP failed, if STP failed, what will happen is the blocking port will become forwarding, then a loop will occur. To avoid that, what this bridge assurance do is, bridge assurance will put the interface as inconsistency state, for which log will be generated and sent to the administrator, and administrator can come and deal with this problem. Right, so the bridge assurance get enabled, and this will be useful only when we have multiple ether channel, so that there will be some STP job going on there. Because we have ether channel, single ether channel, there is no need of STP here anyway. Discussing is bridge assurance gets enabled. Bridge assurance gets enabled automatically when we define it as peer link. The next is one last thing, the final thing. What is that? We go and make the VPC members. We go and say Ethernet 1/0. It is a VPC. It's a VPC member interface. So that's the last thing that we need to do. So what's the port channel number in the down? It is PO1. It should be the same port channel we need to give for this VPC. So let's start it. I go under Ethernet 1/1. Configuration, config T. I'll go under interface Ethernet 1/1. I say switch port. And then I say channel group. You belong to Ether channel 1. So we say this. Next is the final step. I go under this channel group now, interface port channel 1, and I say you are VPC. Now I need to give some number here that can be the same number, can be different also. Let's say I give 11 here. So when I configure on the other side, it should be the same. I cannot say VPC 11 here and VPC 22 here. It should be the same. For consistency, mostly people keep the same number. If port channel is 1, they also keep VPC number 1, but not really mandatory. This can be different number. That's just an identification that groups, that helps these two switches to identify. And this port channel number is to identify the downstream switch. And this is for the synchronization. Whatever is received on this switch, on this interface, will be synced with the right hand side switch on this interface E1/1. We need this number. So this is how the VPC can be configured when we have a server or a switch as a downstream. The next thing what we are going to do is same diagram. I don't want to take the same diagram. Same configuration, everything. Okay. So let me redraw again. Same diagram. I am drawing it again. N5K1, N5K2. Two device, as we already had, and we got two links. We got PO2 here, and we got Ethernet 1/1, and this is Ethernet 1/2 and Ethernet 1/3, and we got management 0 interface 10.0.0.1, and we got another management interface 10.0.0.2, and we were able to ping, and we made this as Keepalive link. So we are not going to do this again, we already did, and this also we are not going to do again because peer link is already established. There is no change in this. Now what is new here is we got a fax box. To the fax box we have servers or switches connected down. So some extra configuration needed. I should not say it as Nexus 2K1. Anyway, it is also kind of switch, but it's not a switch, it's a fabric extender, that's all. Fax 1, Fax 2, let's call it Fax 1, Fax 2. So I got one interface connected to this fax box, and I may have some servers here or some later switches or anything. This is the aggregation layer, so definitely I will have access layer switches or even some servers I may have likewise. So I need redundant connection, so I got this link connected to this one. So let me call it as Ethernet 1/2. 1/2 of right hand side switch is connected to left hand side fabric extender, and 1/1 of left hand side is directly connected to this fabric extender. To identify this fabric extender, let me give a name as 111. This is the fax number for this switch. Where do I configure? I configure it on here. When I do configuration, I'll show you 111. To identify this device, I'll give 222. So this is our plan. Similarly, for all the traffic that is coming from this layer 2 switch or the server, I have another link here. So here E1/1 is directly connected to 222, and here E1/2 is connected from left to right hand side fax box. So what we need is we need two VPCs, one ether channel. Let us say the number for this is PO1, which we already let's have some new number. I don't want to confuse. So let's say 3, PO3, and this is port channel 4. So when I do VPC for this link and this link, so that is going from one bundle. When I do VPC, that should be what? Ether channel or VPC using port channel 3. When I do it for this one and this one, I need to use port channel VPC that will use port channel 4. So this thing I need to keep in mind before I start. So we are not going to do again Keepalive, peer link. We are going straight to this configurations. Now if you see, Ethernet 1/1 is connected to 11 fax, 111 fax, 111. That's the fax number that we have taken for an example. and Ethernet 1/2 is connected to 222.111. Only this much you need to remember. And Ether channel 1/1 should be a member of what port channel? P03. Ethernet 1/2 should be a member of port channel 4. So this thing we need to remember and configure. Configuration will be similar on both the sides. So I'll show it on one side. It will be the same on the other side. So I'll go under on N5K1 global configuration mode. I go under that interface. What's the interface name? 1. Okay, I'm sorry. I cannot use 2. 2 is already used. So let's say 4. So I'll go to interface Ethernet 1/1, and then I'll say you are a FEX interface. So you are associated to FEX association, FEX associate 111, and you are the mode, not access mode, you are FEX fabric mode. Switch port mode FEX fabric, FEX fabric. So this is for 1/1. So what I'll do for 1/4, for 1/4, FEX associate 222. Why? You see, 1/4 is connected to 222. So we say 222, and then we say switch port mode FEX fabric. Now copy the same thing on the other switch, because the interface name is also same, so no need to worry. Now one thing I remember, what is that? When you make this peer link, try to put one interface from one module, another interface from other module, and each should be of 10 Gbps per second. Each should be 10 Gbps recommended, and you need 20 Gbps, and try to have from different module, so that even if one module goes down, there will be another module. And this should not be a shared interface. In some module, you know that 4 interfaces shares 10 Gbps. So we need to shut down all these 3 and make this as dedicated. In some class before, I took this. So it should be dedicated links of 10 Gbps. Okay. Now coming back to this, we have defined first thing, like E1/1 is associated with this, and E1/4 is associated with this. One last thing. Right, what is that? We will go and create the VPC and assign this as the member. So going under Ethernet 1/1 on N5K1, config interface Ethernet 1/1, I'll say channel group You remember we discussed like 3. For this it is 3, and for this it is 4 because it's connected to P4. So we will say here channel group number 3, and then we'll go inside that port channel 3 and do what? Same thing what you did in the old scenario. In the old scenario, what we did is we said VPC some number. We went under the interface, created a channel group, we said VPC some number. Same like that. Here I go under this and give VPC some number, and it should be the same number when I configure on the other switch. So all things should be same. If I use VPC 3, here also it should be VPC 3. Can I use 3 here and 3 here? You can use. Can I use 3 here and 33 here? Yes. So all should be same on both the sides. That's all. Now one more interface. If I finish, your VPC is done using FX. So I'll say N5K1 config interface Ethernet 1 / I think we got 4 there, and then channel group 4 interface port channel 4. Inside the port channel I'll say VPC 44. Same command, same configuration on both the sides. That's it. All that we need for exam. Most of things are okay, but still there are some normal switching based command, like making this interface as trunk interface, allowing the VLANs. So those things need to be configured if you want according to your company's need. So those things we didn't discuss. The common thing, only VPC related things we saw. So when we configure trunk, VLANs, allow VLANs, port channel, all those, some other quality of service thing and many more which we are going to see in the theory class, we need to be very careful. It should be consistent. If I allow VLAN 10, VLAN 20, I must allow VLAN 10 and 20 here. If I forgot to allow one VLAN, then it will be inconsistent. So there are two different levels of consistency which we will be seeing in the theory class, which we have not covered so far. Hope you understood the configuration part of virtual port channel VPC. Right, so we'll stop here.